abbreviate it. So page 17 is constant of proportionality. We abbreviate it as COP. Constant of proportionality. And page 18 is constant of proportionality graphs. COP. Way easier than writing constant of proportionality.
Wait, are we doing 2 today?
Yep, we're going to do 2 today because remember we glued in some graphs. We glued in 2 problems on page 18. So we're going to use those 2 graphs today. Because if you look, here's page 18. Remember we glued something in there. So we're going to look at that because I figured you didn't want to draw those graphs by yourself. All right, we're going to write the full title on page 17 again. Constant of proportionality. P-R-O. P-O-R. T-I-O-N-A-L-I-T-Y. Proportionality. If you need to look, it's on page 18. It's the last words in the question number 1 and question number 2, constant of proportionality. There's my pencil. All right. Here we go. We're going to do a definition. Well, first we're going to write our abbreviation. One more time, writing this whole thing out. Constant of proportionality. And because constant of proportionality is such a pain to write, we're going to call it the C-O-P. The C-O-P. That way we don't have to write it 1,000 times. Sounds good to me. And there are some really, how do I want to say this? There are things that have to happen in order for constant of proportionality to happen. So, big idea number 1. Constant of proportionality, COP, is the unit rate. COP, the constant of proportionality, is the unit rate. And if we remember, the unit rate is a ratio of a number over the number 1. It can be any number in the numerator, right? Any number, but the denominator has to be the number 1. And because it's a rate, my labels are different. Money compared to donuts. Money and donuts are different things. I cannot go to the store and pay for my groceries in donuts because they're not the same as money. Big idea number 2. When using ordered, that's not how you spell it. Ordered, O-R-D-E-R-E-D. When using ordered pairs, an ordered pair. That sounds familiar. It's on a graph. An ordered pair is X, comma, Y. Have you ever graphed something like that before? Yeah. X, comma, Y. The COP is Y over X. Y over X. Make sure you're getting this written down. When using ordered pairs X, comma, Y, the COP is Y over X. What if Y over X isn't a unit rate? What if it doesn't have a 1 on the bottom? Can you fix that? Yeah, we learned how to fix that. If you do this and the bottom number, your denominator, is not 1, can I figure out how to get it to 1? Sure. We divide numerator divided by denominator. You can make it a unit rate. And last big idea. You must, no options, no negotiation, have 0, 0. You must have 0, 0. Do you remember what that's called on a graph? 0, 0, right in the middle. It's called the origin. Have you heard that word before? The origin. It sounds like original, right? It's where you start. The origin of the story is the very beginning. It's 0, 0. Okay, let's do some work. Here's our situation. A store sells 10 pounds. A store sells 10 pounds of bananas. B-A-N-A-N-A-S. Bananas. For $5.90. So if I go to the store and I buy 10 pounds of bananas, it's going to cost me $5.90 for 10 pounds of bananas. It's a lot of bananas. Let's make a table. Pounds is my X. The top number is my X. Pounds is my X. Price, which is money, is my Y. If I go to the store and I buy 10 pounds of bananas, I have to pay $5.90 before taxes. Is it going to cost more with taxes or less? More. Those taxes, they always get you, huh? All right, here comes my table. Good thing we've done a lot of table work, huh? I want to figure out, I want to fill in this table for 0 pounds of bananas, 1 pound of bananas, 5 pounds of bananas, and 10 pounds of bananas. Oh wait, I know 10 pounds. How much does 10 pounds cost me? $5.90. How can I figure this out? How can I figure out my constant of proportionality? What are the 3 things that constant of proportionality has to have? What are my 3 big ideas? What's number 1? Unit rate. So I have to make it a unit rate. I have to have a ratio. Do I have a ratio? Yes. I know 10 pounds is $5.90. So I have to make it a unit rate. The second big idea is when using ordered pairs, x comma y, I'm going to do y divided by x. I have to flip it. So constant of proportionality is tricky sometimes. My constant of proportionality, I'm not going to write 10 over $5.90. I'm going to write what? It says y over x. You got it. $5.90 over 10. But didn't you just tell me that it had to be a unit rate? That's not a unit rate. How do I change that to a unit rate? Divide. Good. Numerator divided by denominator is my unit rate of 1 banana. What is my unit rate of 1 banana? 59 cents. $5.90 divided by 10 is 59 cents. So I can put that boop boop right here. How can I figure out how much 5 pounds of bananas cost? What can I do? If I know 1 pound of banana costs 59 cents, I can multiply. 1 times 5 is 5. 59 cents times 5 is $2.95. The last thing that I have to look for is it has to have 0, 0. It has to. So here's my question. If you buy 0 pounds of bananas, how much money do you pay? $0. And it does have 0, 0, so I'm good to go. Sometimes it's not that way. If I was renting movies from Amazon Prime, and I rent 0 movies, I still am paying for Amazon Prime, right? I'm still paying a membership. So it's not 0, 0. I'm still paying money. So sometimes you do not have a 0, 0 relationship. Lots of times you do. All right, let's look at problem 1. This is a graph. It's the same thing. We have 3 things that we have to talk about. Let me zoom way in for you guys here. It says the graph below represents the total number of plants and the number of seed packets used. What is the constant of proportionality? So, if you look, this spot right here, that's an ordered pair. That spot right there is an ordered pair. It's x, comma, y. Do you agree? That's what it looks like to graph. What are the numbers that I should put instead of x and y? If I start here, x is over, y is vertical. What's my over number? What's my up number? How many do you go over? 1, right? So 1, comma. How many do you go up? Do you go up 1? You go up 1 space, but what number is that? 10. 1 over 10. Or not 1 over 10, 1 comma 10. So my constant of proportionality, remember, is y over x. So what should I put down for my constant of proportionality? What is the y number? What is the x number? The x number is 1. What's my y number? 10. So I'm going to put 10 over 1. Is that a unit rate? But I need to put my labels. Where are my labels? What does 10 represent? What does 1 represent? 10 plants and 1 seed packet. I'm just going to put packet. There we go. Does it go through 0, 0, the origin? If I have 0 plants, does that mean 0 seed packets? Yes. All right, let's try number 2. Right there's my ordered pair. This is the number of cups of coffee and the total amount of sugar required to make the coffee. So it's x, comma, y. What do you think my ordered pair is for this one? How many do I go over? How many do I go up? How many do I go over? Awesome. I go over 4. I go up 1 space, but what's my number? 20. Fantastic. So let's find our constant of proportionality. Whew. Good thing we have an abbreviation. Remember, constant of proportionality is y over x. So you have to use your ordered pair. What's my ordered pair? Y over x. What am I going to put down? Excellent. 20 over 4. Is that a unit rate? No, it is not. Can I make it a unit rate? Perfect. How do you make it a unit rate? Divide. Numerator divided by denominator. Grab that calculator. 20 divided by 4 is 5 over 1. Good. You have to have that 1. But I'm not done yet. We're almost there. I have to label it. 5 what? 1 what? 5 cups of coffee to 1 pound of sugar. That's ridiculous. That's too much sugar. You're gonna have a headache. Last question. Is it a 0-0 relationship? If you have 0 cups of coffee, did you use 0 pounds of sugar? Yes. So it works. It met all 3 requirements.